Hello, everyone. Welcome to Goucher Environmental Dialogues, and thank you for joining us this afternoon. I'm Dr. Jen DeRosa. I'm the director of our master's degree program in environmental sustainability and management here at Goucher College. And if this is your first time joining our Goucher Environmental Dialogue speaker series, just to give you some background information, we are a web-based speaker series. And our goal with this speaker series is to feature cultivated conversations with environmental, sustainability, and climate leaders and visionaries and innovators. And as I mentioned, this is hosted by our master's degree program in environmental sustainability and management. And if you have any questions about that particular degree program, like learning more about our curriculum or admissions or anything like that, I am hosting an information session on May 8th at 1 p.m. I'm posting our link tree here in the chat, which includes links to our social media and event registration and also our webpage. But I will happily share the link to that when I share out the recording from today's event in about a day or two. So stay tuned for more information about future Goucher environmental dialogues. But our conversation today is a very timely conversation. We're having a conversation about PFAS, plastics, and pesticides. And our guest is from Goucher College. She's an environmental chemist, Dr. Rebekah Gray. And Rebekah Gray received her bachelor's degree in chemistry and biology from Carlow University in Pittsburgh, Pennsylvania. She was then employed as a chemist at Environmental Services Lab for a year before returning to her PhD in analytical chemistry at The Ohio State University. And Rebekah's graduate research focused on assessing the environmental friendliness of supercritical fluid chromatography and developing carbon materials for use in separation science. Now, following graduate school, Rebekah was a postdoctoral scholar at the College of Worcester, and her research focused really shifted at that time towards environmental chemistry, where she analyzed precipitation for pesticides using high-resolution mass spectrometry. I always stumble over that word. And this work was actually published in the journal Atmospheric Environment, if you're interested in digging more after our conversation. So Rebekah started at Goucher College when I did in 2023, and she teaches here general chemistry, analytical chemistry, and environmental chemistry. So we're very excited to have her as our guest today. And I think I warned everyone in my email this morning, since this is a webinar format, you can't turn on your video and you can't turn on your audio, but we encourage you to interact in the chat. And please join me by giving a warm welcome to Rebekah by indicating in the chat where you're logging in from, because it's always fun to see that. And also, throughout my conversation with Dr. Gray today, if you have any questions that you would like me to give voice to, please type them in the chat, and I'll make sure I weave those in either the middle or the end of our conversation. All right, so welcome everyone, and hello, Rebekah. Thank you for joining us today.
Yeah, very excited to be here.
Yeah, so I was so excited to read about your work, and my first question, though, is really, I always like to understand people's background, like what led you to this? So what led you to a career in environmental chemistry?
Yeah, so I guess, even starting from high school in my chemistry class, I was really interested in that. It just explained so much of like what I was seeing of the world around me. There was always some sort of explanation. I'm like, that's great. That's kind of what I'm looking for. But throughout college, I didn't really know what kind of job I wanted to do. I tossed around a lot of ideas. I kind of knew I wanted to be helping somebody in some way. So, I think the normal ones people throw out there, like, should I be a physician? Should I be a teacher? I guess I kind of went the teacher route with Goucher College, but I didn't really know. That's how I ended up in the environmental lab for a year after undergrad. It was like near my hometown, so it was really easy, and I just got interested then in the environmental aspect and how that could be a way providing information to help people. We were doing a lot of like wastewater and drinking water testing, and I'm like, this is going directly, this knowledge to help someone, either clean up their drinking water or something like that. And so I was like, that's awesome. So I still like the teaching aspect though. So that kind of led me back to grad school instead of just sticking in a bachelor's level position. And so kind of double whammy, helping people now, teaching and some research.
Oh, that's excellent. Yeah, that's what I enjoy too about being in our position is you get to interact and educate, but you also get to keep working in the field as well. And
Right.
in your case, coming up with some really fascinating discoveries. So you've done quite a bit of work. Let's start with microplastics, I guess, of our PFAS plastic pesticide
Yes.
triangle. You've Let's start with what are microplastics for those in our audience that maybe have heard the term but aren't 100% sure what that is. And how do microplastics get into the soil?
Yeah, so microplastics are just a term that we use whenever we're thinking about how plastics break down. They're not going to break down into like their individual molecules or atoms. They just break into smaller chunks of plastic. So we start using the term microplastic whenever these chunks are about 5 millimeters or less. And we even have a term nanoplastics for whenever they get really, really small. So it's kind of indicating that they are, smaller than your, water bottle you might toss in the trash. And it's yeah, for how they get in the soil, it does come a lot from disposal of different wastes. So a lot of this contamination is around landfills in surrounding areas, as well as people litter, of course, and that can eventually break down into microplastics in areas where you might not expect them.
Okay, so that thanks for that description that because that helps me. My students know I'm a gardener, so they know I spend like a lot of time in the soil and I get really nerdy over
Yes.
plants. So then I have a question. If we see them breaking down and they're in the soil,
Mhm.
just how pervasive are they in the environment? Like, do they beyond the soil? Where else might we find these?
Right. Yeah. So I guess their starting place would be the soil environment. But especially if we think about soil being kicked up, manually or by the wind, even this can carry them to other locations. So everywhere scientists have looked so far, they have found microplastics of soil, water, the air just being kind of blown around, and even really remote locations. So it's not just down the street. People have found them in Antarctica. So
Oh,
it's
yikes.
they're everywhere. Yeah, it's
Yeah.
unfortunate.
I think I had read that they were even found at the bottom of one of the deep ocean trenches, which was very
Yeah.
surprising. Yeah. So found everywhere. So why is
Yes.
this something that people should be concerned about?
Right. So a lot of the concern is animals ingesting them.
Mhm.
Right. This can build up in their intestinal tracts, especially if we think about smaller animals like fish. One of the kind of the overarching concerns with microplastics is that they can absorb other contaminants, or I mean, not even contaminants, just other molecules in general. So they become kind of stuck to that microplastic, and those can be carried around all the various aspects of the environment. And if they are, a contaminant that have some sort of toxicity, that's kind of, an additional concern then for any animal that happens to ingest them.
Oh, that is surprising. So we think of them as being sticky, essentially, where other things adhere
Yeah,
to them. Okay.
right.
And another question that kind of jumped in my mind based on your description. So are people, if they're eating animals that have the microplastics, are they ingesting them and getting them in their own bodies now? Are we finding microplastics inside people?
Yeah, we are actually. And this mostly does come from like eating other animals. It could be stored not just in their intestinal tracts. We generally don't eat those, but they can move into the tissues of those animals as well. And that's kind of how we get exposed to them most often.
Oh, yikes. Do you know if anything is being done? I know there's a lot of like awareness campaigns. Is anything being done to clean up the microplastics? Just curious.
Yeah, I would think most of the cleanup is starting with before they get to the microplastic stage is just,
Okay.
trying to reduce overall garbage disposal, like properly disposing of things. One thing, because there are a couple like products that contain things that would be considered microplastics. Like you might remember a really old face scrub that had those little microplastic beads in them.
Yeah.
That kind of thing has been phased out for the most part. So kind of that would be a direct introduction of microplastics, but now we're really focused on proper trash disposal so it doesn't end up in our environment.
Okay, that makes sense. And I know like there's quite a bit of movement for reducing single-use plastic, which I imagine would help significantly if we reduce our consumption of single-use plastic.
Right.
We have a question in the chat, which
Ooh,
is
yeah.
timely because it fits with our conversation on microplastics. What detrimental medical effects on humans and animals are linked to microplastics? Or is there any specific studies that you can point us to? Um, any thoughts on that?
Yeah, I guess I don't directly interface with like the medical aspect. I know it's like
Mhm.
still under investigation, just because people are realizing that they are so prevalent in our environment as pretty recently, last decade or so.
Mhm.
So that's definitely something that a lot of people are researching is kind of what effects do the microplastics themselves have, as well as what sticks to them and what kind of problems can that cause as well. So I guess I don't know any studies directly. I'm not on the medical side of it, but people are definitely working on that because it is such a big question.
Mhm.
Is it really bad?
Yeah, I would think, and this is just my curiosity. I would think that both are bad, right? But and the chemicals that are adhering to the microplastics, again, like an introduction to the human system, that's not natural. So yeah, it'd
Right.
be it'd be interesting to dig into some of the medical research to find out, like, what are they finding.
Right.
And probably very disturbing as well. um
Yeah.
yeah. So I also wanted to ask you about PFAS, because I know this has been in the news recently because of the EPA's new kind of shift in how they're treating PFAS. But let's start with what are PFAS, and where do they come from?
Yeah, so PFAS is an acronym for perfluoroalkyl substances, and that's a long science term. But basically, what we're looking at is a chain of carbon atoms that have two fluorines on each carbon, and then they have some sort of group at the end that has a lot of oxygens.
Mm.
And the way this structure is set up, the oxygen containing kind of head group is really polar, so likes to be interacting with water, whereas the chain part is nonpolar, so it doesn't want to be around water at all. So used a lot in like water resistant clothing. We just don't want the water to stick to it. Non-stick cookware is another big place you might find PFAS.
Mhm.
One that I find interesting that we don't often, those are things we use pretty often. But firefighting foams also contain PFAS. So if you
Hmm.
have that sprayed in your location, that's also kind of it's able to smother flames too. But the
Mhm.
major component's kind of like this non-stickiness.
So would we also find PFAS in, like, I know when my kids were little, you could buy like fire resistant pajamas for like little
Ooh.
kids. So I'm curious, is that something that might also have PFAS in it? Anything that's got like a
Yeah, I could see. I don't know for sure, but I could see how it would. That would be
yeah,
just kind of a resistant material. Is what,
okay.
yeah.
Yeah, I mean, I don't
Huh,
even know if
that's
they still
interesting. I
I
didn't
don't
know
know if
that
they
was a
still
thing.
I don't know if they still make that, but like my kids are like in their older teens and 20s now. But I remember like that was a thing. You'd go to
Huh.
Target and they'd be like, "Oh, these are fire resistant pajamas."
Oh,
So
wow.
I don't know. It was a weird thing to advertise. Um,
Yeah.
so chemically speaking, and I know I've heard sometimes PFAS are referred to as forever chemicals. Um, so why is that they're referred to forever chemicals? And then chemically speaking, is there variation in the types of PFAS?
Yeah, so going off with the forever chemicals, right? These are not really breaking down, and that has to do with that carbon fluorine bond. Those are really, really strong bonds, so near impossible to break them without a great input of energy. So they're going to stay, that structure for a very long time. But yeah, variation would be kind of in both the groups that I had mentioned. So the polar group can change its structure a little bit. The main focus, though, is that like long carbon chain. It can be a variety of lengths. I think the first type of PFAS made were like 8 carbons long. But now we have shorter and longer chains depending on kind of the properties that we need from that molecule.
Okay, and do they all have the same, I want to call them like almost half-life. I don't even know if that's the right term, but like, do they all have the same kind of persistence in the environment, or are some of them not quite as bad as others?
Yeah, so the shorter chain are not quite as bad. They're still going to persist for a long time, but because there's less of those carbon fluorine bonds, they're a little better. And if you happen to break one, now you've kind of disrupted the whole structure. Whereas those longer carbon chains are a lot more carbon fluorine bonds, and they bioaccumulate pretty easily, just because they're more nonpolar than they are polar now. And so they can collect in different environments in your tissues. It's very fun.
Now, are these like the microplastics in the sense that do we find them everywhere as well, or more concentrated around like human processes?
This is another one that we have found in nearly every environment that we've looked so far. So yeah, deep oceans, remote areas. I saw a talk once at a conference where they were sampling shark's blood from that live deep in the ocean and found PFAS there. And I'm like, that is wild.
That is wild. Yeah, that's really disturbing.
Right.
So do we know about their health effects to some extent? Like what in terms of, I know most of us are now worried, like, is this in my blood? And if so, like, what does that mean in terms of health effects?
Yeah, so with this nonpolar chain, they kind of act like cholesterol, right there, because that's basically what cholesterol is another long chain of nonpolar material. And so they, kind of accumulate and can cause cardiovascular issues is the major one.
Oh, that's not good considering we have heart disease really high on the list of
Yeah.
problems. Okay, and there's a couple questions in the chat. How do we limit our exposure and protect ourselves as consumers from the abundance of, you've mentioned microplastics and PFAS, and we'll get to pesticides in a second, but when it comes to these, both either microplastics or PFAS?
Yeah, one thing that jumps to mind immediately about limiting exposure to PFAS is from that nonstick cookware. I know I've started switching out to stainless steel and cast iron, as opposed to that Teflon coated stuff. That's a really easy way, I think, for us to directly influence the PFAS that we're intaking or not. Just kind of on a larger scale, kind of limiting those products that are made. There has to be better options for making something non-stick than these things that will essentially last forever.
Yeah, and when you think about it, your food, if you have a Teflon pan, you're cooking your food directly on that. So that's just a direct point of contact.
Right.
I interestingly enough was buying pots and pans as a gift for the holidays for my mother-in-law, and I noticed one of the, I forget, I'm not going to do a shameless plug for the company, but but I noticed that they had non-stick pots, but they were considered green, and when I dug into the labeling, they were certified as not having PFAS in their non-stick coating. And I still don't know anything about the chemistry of that non-stick coating, but they had green non-stick or something like that. So
yeah, I wonder what that
who knows?
material is.
I
Yeah,
don't
I know
know.
I've seen advertised on pots and pans. So right, PFAS is the general acronym, but then each specific compound has its own little acronym. And that 8 carbon chain always has an O in it. So PFOA to indicate octane, oct8. And so a lot of pans are advertised as not having that PFAS, but then they'll have other ones. And so that don't tell you about. Because that's the one I think most people may have heard of. If they're in the PFAS world, it's PFOA or PFOS. So I know a lot of pans kind of advertise that they're free of those.
But we may have one of the other 12,000 PFAS.
Right.
Oh dear. Well, that's really good to know. And I wanted to dig into also more about where you're finding the PFAS. So in one of your studies, I was reading that you found PFAS in rainwater, and it didn't match any known PFAS manufactured to date. So what does that mean? Does that mean that the chemicals are changing out there in the environment?
Yeah, so we tossed that question around a lot because, again, we were going off the assumption, these are forever chemicals. They're never really changing their structure. So we still kind of stuck with that. Explanation is that the environment wasn't changing them a lot. But we went back to maybe how they were produced, right? You're making a target compound, you're trying to make this 8-chain long something. But, chemical reactions are never 100% successful. They can make some byproducts. So that's kind of what we were attributing it to, was that during the manufacturing, we saw a lot of branching PFAS. So what that means is, like, if your 8 carbon chain was going to be, linear right in a row, there still could be 8 carbons, but it may only be 6 in a chain, and you kind of have like 2 offshoots, and that would be a branching PFAS. And we saw a lot of those. So we were just thinking that was probably due to the manufacturing process not being 100%. So yeah, our point was really like, either we need to get a better manufacturing process to produce what we're actually saying we're producing, or just better reporting of these byproducts in general. Because it's not like they're not testing the purity of their compound. I mean, they probably are, and so they know that it's not 100%. So,
Well, that's reassuring to know, I guess, that they're not. I don't know if that's good or bad to think of, if they're not out there in the environment, like chemically changing over time. But then again, maybe if they were out there in the environment chemically changing over time, they would be not as dangerous. I don't know.
yeah, that's
Okay.
kind of the side that I lead on to, is like, I think I want them to change in the environment a little.
Okay. Well, so, and then this, I noticed that the EPA just regulated certain PFAS, not all the PFAS. Are those, what can you tell me about the ones that they just regulated, or have you been reading up on that? Just making
Yeah,
sure.
I've been
Okay.
skimming a little.
Okay.
Yeah, so a lot of the ones the EPA regulates are like the most commonly used ones. But yeah, they're missing some of these branching ones, or sometimes like the carbon chain doesn't need to be 2 fluorines. Sometimes it only has 1, again, kind of a manufacturing, byproduct. So these are not ones they're catching or regularly monitoring. They're assuming it's a low enough concentration that's not a concern. But yeah, based on what we found in rainwater, they were, they're in a decent amount. I still wouldn't say substantial, but they were there, they were detectable.
And so it sounds like EPA is using the Safe Drinking Water Act to regulate these, and so they've established certain thresholds.
Yeah.
But does that mean, though, so that means that they're only going to test for those that they've identified and they have a lot of research on. So
Yes.
there's lots of PFAS though, right? So we
Yeah.
need a lot more environmental chemists digging into that research, and so that,
Right.
okay, so it's a start, but it's not.
Yeah, it's a start, but I think, baby steps to get there, but
Okay. I think we're like, okay, let's go, let's go. But so we also have another question that kind of piggybacks off this in terms of like testing. You tested the rainwater, and they're
Mhm.
also asking about, is there anything people can do to test like blood work to find out if they have this in their
Mhm.
bodies? So in terms of PFAS testing, how labor intensive is it to find out what PFAS are in rain droplets?
Yeah, so I guess it depends like how extensive you want to get on your testing. So like the EPA list of things that they monitor for. Those would be really easy to buy standards for, and like kind of confirm that
Mhm.
if your chemical information you get from the instrument matches or not. Yeah, but the problem then would be kind of these more exotic PFAS, if I'll use that word, that people don't often test for, would be a little tricky. The actual analysis wasn't too bad. It was more the data analysis, because we were specifically looking for things we didn't really expect to see. We were
Okay.
seeing what we could find in general. But if you have like, yeah, a list of, 10 or so, that would be a relatively easy analysis.
But if someone, so like with the case with the shark's blood getting tested, or in the case of someone wanting to get their own blood tested, is there currently a way to do that through like a doctor's office, or is that something that they'd have to go
Hmm.
to a chemist for?
I would imagine a chemist. I guess like the only organic molecules I can imagine, uh, not a dentist. Oh gosh, a doctor testing for would be like, yeah, cholesterol type things. I'm not sure they're quite set up for quick, rapid PFAS analysis, but a chemist could do that
Okay.
relatively easily.
Okay, yeah, because I was thinking of like the lead testing that's done, right? If you
Hmm.
think there's been exposure to lead, that's usually a simple blood test, but it doesn't
Yeah, I don't know if
seem
the
we're there yet, right?
medical is up, yeah, on the regular testing of that.
Yeah. Yeah, maybe that's something we should definitely be advocating for. Although I think people
Maybe.
would be shocked to find out how much exposure we've had to these.
I think
Um,
so.
and then another useful question before we go into pesticides. what kind of strategies do you recommend to people that are trying to promote awareness of this issue, especially um, for people that I think the problem that we deal with in like science communication with something like PFAS and microplastics and pesticides is they're largely invisible to the human eye. So a lot of people feel like, well, if I can't see it, it's not a problem. So what do you recommend? Because I know that there's listeners out there that are very strong environmental advocates. What can you recommend to them in terms of promoting awareness or communicating or trying to talk about this?
Right. Yeah, I think just making, yeah, because you're totally right that a lot of people don't consider contamination at all because these are little molecules. You still can't see them. And a lot of their uses are really good. Like people like nonstick cookware. So people are hesitant to, even think about something that's beneficial to them potentially being harmful as well. So I think just, yeah, continuing to advocate for greener materials, maybe if you have a stubborn relative, buy them some non-PFAS cookware, like just
Yeah.
kind of, yeah,
Yeah.
yeah. So thinking kind of that, making these little personal changes within kind
Mhm.
of your circle, I think can, deter companies also then if they see we don't want this, coated material, they will switch to something else that hopefully
Yeah.
is better, but hard to say.
Yeah, that makes sense. Like essentially voting with your dollars and showing your influence that way.
Right.
Yeah, that makes sense. Although the times that I've gone into a rainforest, I've really liked that water resistant or waterproof
That's true. Yeah, like it's
gear.
so good.
So there's a couple of those that I'm like, I mean, can we make it greener? Of course, but
Right.
there's a need for that, definitely. Um, Excellent. So I was also thinking too, a lot of this kind of development and work and research around PFAS reminds me of um, a lot of that earlier research into pesticides that was happening like in the 1960s and when Rachel Carson
Yeah.
wrote Silent Spring, because a lot of people didn't
Right.
realize how dangerous some of those pesticides were. And I know pesticides have come a long way, but
Mhm.
that's a good pivot though. Let's talk about your pesticide work. First, can you give me a summary or our audience of a summary of the different types of pesticides that are typically used in the environment? Because not all pesticides are the same.
Right. Yeah. Pesticide, another like umbrella term. And so kind of anything that you're trying to deter is going to have its own unique names. There's, one for birds, one for slugs that have its own
Mhm.
name. But the most common ones that are widely used, especially like in the agricultural industry, are herbicides for plants and weeds, fungicides, of course, for fungus, insecticides for insects. Those are kind of the big three that make up the vast majority of pesticide use around the world.
And what are the hazards? Well, before I get to the atmosphere, what are the hazards of using pesticides?
Right. So yeah, like you've said, they used to be really, really bad, like DDT, thinking about
Mhm.
that. And they have gotten better, but the major concern is just toxicity on, you know, plants or animals that you don't want to target.
Mhm.
So we want to really kind of design these to be specific for the, organism that we want to kill or deter. From that region and kind of limit its toxicity for other types of animals.
Mhm. Yeah, that makes sense. And that includes even our own toxicity. I don't know how many people I've seen in my lifetime spraying pesticides around their home garden or
Yeah.
fungicides like in flip-flops and then you get it on
Oh,
your feet. I mean, like any kind of skin contact is an
right.
exposure. And if you don't
Yeah.
wash your hands and then you go eat lunch, that's not good. So
That's not
yeah,
good. Wash your hands.
yeah. So I would recommend people the one thing that I think is really well done about pesticides because of the EPA and regulations is they all have a chemical label with all of the information that you need about applying it.
Yeah.
But I don't think most people read that label. So so that has me a little worried. So um, your work was on pesticides in the atmosphere. Can you tell me more
Mhm.
about what you found and what you did?
Yeah, so this was really fun work, and it was a lot of field work, which I had never done before this project. So we collected rain and snow samples for a 3-year period. So we had like 100 or so samples. It was very fun. And we found a lot of pesticides in that rain and snow over the course of 3 years. I think it was about 23 unique pesticides throughout this sampling period. And about a dozen of them were found pretty frequently in about 20% or more of the samples. So that was interesting. It was also mostly herbicides that were used in agriculture. So the work I was doing was Northeast Ohio region. So
Okay.
of course, a lot of farms around there. So the
Yeah.
fact that we saw a lot of herbicides weren't, that wasn't shocking to us.
Hmm.
Um, just because we were in such an area that was going to use them pretty heavily. There was one compound that we found that kind of surprised me. So it's an insect repellent, DEET. So if you've ever used like off bug spray, that's the major ingredient in
Yeah.
that product. And yeah, so again, sampled for 3 years, we found DEET in 100% of our samples.
Oh,
And so
wow.
that was wild because it wasn't even just like agricultural use. That was much more of like a personal use product. Like, yeah, big farms don't use DEET too
Hmm.
often. So that was kind of something that humans, regular people, were contributing to. So that was
Yeah.
very, very interesting.
Oh, so I guess now me, the geo person, I'm starting to think about like, okay, how's it getting into the atmosphere? And it makes sense with some of those intensified like farm procedures with the massive spraying, but like DEET is something we're just spraying on ourselves. So
Right.
is it is it going up into the atmosphere from just us spraying us, or is it washing off and going into the water system and then going into the atmosphere? So, and that may not be something you can answer with your
That's
study, but
okay.
I'm
I
just
have
curious
some
what.
thoughts.
Okay, yeah, I'd love to know what your thoughts are on that.
Yeah, so I think it's some of both actually. So the
Okay.
spray, right, it's naturally a mist. It's not all ending up on your skin. Some will, float away on these little droplets that you've just sprayed. But I do also think it is just being washed away. I actually learned on my interview here that kayakers will often like coat their kayaks in DEET, just like a
Oh,
solid DEET bar. And so that is
oh,
easy to understand
yeah.
how it could like end up in the waterways
Mhm.
then, and then eventually evaporate and get incorporated into rain. So I do
Yeah.
think it's some of both, and that is what like made this work a little hard to pinpoint. The exact source of where these were coming from. We just kind of could use our data as hypotheses and kind of point like this is something we should be thinking about.
Mhm. Yeah, areas for more research, I think. Yeah, definitely.
Right. Yeah.
Was of the pesticides that you guys found in the rain and snow samples, I guess, do the different chemicals have different kind of residence times in the atmosphere? Has there been any work on that?
Yeah, that wasn't directly what we were interested in, but there are,
Yeah.
yeah, different lifetimes for these pesticides because the light
Okay.
can help break them down. A lot of the
Okay.
pesticides at this point can be broken down photochemically, which is really nice. They don't last forever.
Okay.
But that, depends on how strong those bonds are again. So some do last longer than others. We're thinking like the week to a few months time scale, which is still a long time, but it's not forever.
Yeah. I was gonna say we need to be wearing more like long sleeves instead of spraying deep, but then again,
That could be it.
there's that clothing that's
Yeah,
like soaked in permethrin, so that's probably a
right.
chemical. So
Yeah, again, it's like a
yeah,
very useful thing, but
yeah,
now we see it, yeah, in all of our snow and all of our rain.
yeah. That's very worrisome.
Yeah.
Let me check our questions really fast. We had a question. Are there any specific like home water filters or other water
Hmm.
filtration systems that can filter out these dangerous chemicals like microplastics or even PFAS and pesticides?
Hmm. That's a good question. I'm gonna address microplastics because that's the one that first came to mind. I think
Yeah.
that one's probably the easiest to filter out of your water, unless you get like end up with really, really small ones, because
Hmm.
essentially what a filter is going to do is have like some pores that are a certain size. And so anything larger than that would be really easily filtered out, just
Hmm.
kind of just by getting stuck there. Um, in terms of like the PFAS and pesticides, um, I guess I'm thinking because most filters are like a charcoal
Yeah.
based material, which generally stick like non-polar things, so things that don't want to be in water, but doesn't mean they're not in water.
Mhm.
So that might work. I'm not sure of like the efficiency of that, so don't quote me. But I could imagine they would work reasonably well, just a normal activated charcoal filter.
Oh, yeah, it's good to know because I know that no, I haven't bought one like recently to know like what they advertise on their label, but I think I also heard on NPR a day ago, or maybe it was today when they were talking about PFAS and the EPA's new change, that for the ones that are being regulated, charcoal filters should help, or should
Yeah.
work. So I think it can't hurt, right, to
Yeah, I figured
to run it through
it's
the
knocking
filter.
something out of the water, so that's good.
Yeah. Um, so our next question before I ask it, it kind of piggybacks off what I was going to ask you, which is for those in the audience that are interested in the kind of work you're doing or in environmental chemistry in general, what advice or recommendation would you give to participants that are listening who are interested in getting more involved in this type of work?
Yeah, so I think this is a really great question because, especially if a scientist is collecting like field samples, like the rain and snow water, we are always looking for citizen scientists to help us out with that sample collection, um, even if it's like kind of a distance away from where that research is actually being like targeted, because just having a wider range, geographical area that these samples are being collected can allow us to make more general conclusions about what is in our environment. So if you ever run into anybody that's like, I need to collect rain, like me, hit me up. Then that, yeah, is a great way to get involved. And we even let you play with the instrument sometime, which is fun.
Oh, cool. Yeah, well, I'll definitely remind people that too in the email I send out later with the
Yes.
recording about citizen science. Because yeah, like I'm on Kent Island, so if you ever want rain from Kent Island, we get
Ooh,
lots of that.
okay.
Happy to bring you some rain.
Perfect.
Um, let's see. So some questions we have. Oh, there's a lot of good questions in here.
Nice.
Katie asks what sort of career options or fields of study are relevant to or available with respect to some of these topics.
Yeah, so there are lots of actual, areas that you can formally study that would cover a lot of these areas. I think, chemistry is obviously my favorite, but just environmental science in general, because you even do get into them thinking not just how these molecules are formed and interact, but yeah, more ways to kind of mitigate their risks and think about designing, different molecules to do the same thing, but will be more environmentally friendly. So I think that's a really big area. A lot of STEM can, be incorporated into this green environmental technique. I think a lot of STEM, they're kind of pushing this focus of let's be more environmentally friendly and sustainable. So it's a
Yeah.
good change to see.
Yeah, that's a good shout out for STEM fields,
Woo.
science, technology, engineering, and math. Other questions too. One was, as citizens, how do we push our legislators to ban these chemicals here in the United States? What kind of steps can we take?
Yeah, so I guess I think in a very ideal world that people are swayed by data. But that I guess that might not always be true. But I just think citing these studies that people are doing and showing, it is a prevalent compound, looking at these medical types of research and being like, it causes this issue, this issue, this issue, and just kind of pushing the data on them. I guess I don't know how well legislators listen to data, but it's at least very hard evidence, and to the point you're making.
Yeah, and I agree. I think I'm going to plug to I'm going to shamelessly plug our grad program because we also encourage all of our students to take like an environmental policy class, and then they have the option to focus even more on like communication and public engagement and things like that.
Perfect.
So I think that helps connect like the data of what we're seeing with these chemicals to like how do you put that into action? Like how do you work within the existing policy structure or even develop new policy to address some of
Yeah.
that? So I think, yeah, I mean, I guess what I'm saying is the field of environmental studies is so diverse that there's a need for everybody,
Right.
right? We need our chemists, we need our very persuasive policy analysts
Yes.
and things like that to help to make this aware and also change the situation. A couple more questions. Do you know if there's a proper disposal place for like
Hmm.
clothing, bags, tents that have
Oh,
waterproof materials or coating, especially if it's like flaking
hmm.
off?
That's a
You heard
really
of
good
anything?
question. I have not heard of that, but that's such a great idea. So I think we should start
Yeah.
that. Yeah, I've not heard of anything formally being organized like that, but I think that's a great idea.
Because I think I like where this question is going because we have a whole system in place for like spent batteries and things like that. You're not supposed to
Right.
throw
Yeah,
them in
this
the
is
trash.
not that different
Yeah,
from that, really.
yeah. I think that might be a policy space where there could be a lot more work at like the municipal level is
Yeah.
and working with like the waste disposal of a city like Baltimore as to how to
Right.
collect items like that and how to treat them. So that's a good question.
That's a
Let's
great
see.
question.
Um, and just a reminder too, as I'm scrolling the questions in the chat, if you have any questions for Rebecca, please post them in the chat and I will try to get to them. There's a lot of questions and I'm afraid I'm like scanning over some of them. Um, can you to what extent does a water treatment plant
Mm.
remove microplastics um, from the water as they're being treated?
Yeah. So again, this depends on like the size of them. Some of those bigger ones that are, near the cutoff of that 5 millimeter, will generally settle out of the water. And so they have a lot of mechanisms to collect things that naturally will settle out. It would be the problem where you get into these really, really small microplastics. They do have some sort of filtering in place at most water treatment plants, where they, force the water through a thing with a lot of little pores in it.
Mhm.
And as long as they're bigger than those pores, they will be stopped. But again, yeah, really small ones that have maybe been in the environment a long time, so they've broke down into these small chunks over time, would be a little harder. And I don't think there's a mechanism for things that are like really, really small yet.
Mhm. Well, it's good to know that this is something that's being worked on, especially at water treatment facilities. And I imagine just because of the being more of a physical difference rather than a chemical difference, it's probably easier to catch the microplastics than something like PFAS. Um,
Yeah.
yeah, I mean, just thinking from what you've been explaining, which countries or states, if you know of any, have banned some of these chemicals and materials, such as the
Mm.
different kinds of PFAS? Are you aware of any that have banned them?
So a lot are being phased out actually in the United States now. So like that 8
Hmm.
carbon chain, that was kind of like our starting point with PFAS. That's been phased out-ish.
Okay, okay.
I forget the exact like date that it needed to be phased out by. But that's at least in the process. But yeah, kind of based on that legislation where they had to change. So now we're seeing like a bunch of other different chain lengths of these PFAS because those are a lot less regulated.
Mhm.
So again, in the process, but
Okay. So
yeah.
it's an evolution, it sounds like. I think I read that the company 3M started phasing out their PFAS a few couple years ago, but do you know if that was
Yeah.
all of it or is that just some of
I
it?
think it was I because they were really notorious for making those 8 chain things. Like that was the major company. I didn't want to throw out a company name, but but they kind of started it. And so I know they have been, I think 2009 is when they started phasing it out, somewhere in that zone. So hopefully but then they just manufactured other chain lengths and kind of
Sorry.
got around it. Oh, you're good.
Well, that's good to know, that they're decreasing the use and that sorry, it's allergies.
Oh no.
So sorry. Um, I'm gonna have to mute myself. Hold on one sec. Well, with that being said, there isn't any other questions left, and since I'm on the verge of a coughing attack,
Yeah, geez.
we'll blame the stuff in the atmosphere. I'm just kidding. So I'd like to thank you for being our guest today.
Yeah, this was so much fun.
And thank you everyone who's been joining us. If you would like to follow up with Rebecca, I'll share her email in my follow-up email that I send probably tomorrow. Okay? All right. Thank you guys. And
Awesome.
when I turn us off, we all go away. So you can say thank you in the chat if you wish to while I cough. Hold on.
Oh no.
All right, I'm good. Okay. So thank you very much and have a very nice evening.
Awesome.
All
Thank
right.
you so much.
Bye.